Hello geometers, and welcome to the video on image matrices and how to use them in our rotation and in other things as well. So an image matrix is just a rectangular arrangement of XY coordinates. Now in future courses and future parts of this class, we will learn a lot more about matrices and all of their full power. But as far as transformations is concerned, a matrix is really a great way for us to organize points so that we can perform transformation faster and with fewer errors. So I think I should just give you an example. So let's say I have 3 points, and A, the coordinates are 0, 3. B, the coordinates are -2, -5. And C, the coordinates are 1 and -8. So, this has the x-coordinate of A, the x-coordinate of B, the y-coordinate of C. Sorry, the x-coordinate of C. Now, for us to convert this into an image matrix, we make a sort of a rectangular box with these square brackets, and we're going to label the points along the columns here. And then the first row is going to be the x-coordinates, and the bottom row is going to be the y-coordinates. So A, 0, 3 will be represented 0 for the x-coordinate, 3 for the y-coordinate. B, -2, -5, so -2 for the x-coordinates, -5 for the y-coordinates. C, +1 for the x-coordinate, and -8 for the y-coordinates. So again, this is just another way for us to represent coordinates. Instead of listing them out like this, we can write it as an image matrix. Now let me show you how we can use this image matrix to more effectively and maybe being able to reduce some of our errors. Okay? So let's see. Find the image matrix that represents the rotation of the polygon about the origin, then graph the polygon and the image. So this is the image matrix that we have. We want to rotate it 90 degrees. So remember that this top row here are all the x-coordinates, the bottom row here are all the y-coordinates, and we can graph them. We can use the image matrix to graph. Okay, so I'm going to make sure I include my scale here. And A is 1, 2, so go over 1 up 2, that's A. B is 4, 2. That's B, and C is 3, 4. So that's C right there. So that's our triangle ABC. Now, when we rotate 90 degrees about the origin, then we get this rule that AB becomes -BA. In other words, we're swapping the y-coordinates and the x-coordinates, and then multiplying everything in the top row by -1. So when we do this swap, we're basically taking the top row and replacing it with and the bottom row and just swapping them. So that's the equivalent of swapping B and A. And then we have to multiply the new x-coordinates by -1. So we get this result. Okay? And now graphing it, you can see how quickly that was done, and it's pretty error-free. Not everything is perfect, and nothing is really perfect, but it's easier to avoid errors if you do it this way. So now we can graph this. So this is going to be our coordinates for A prime, this is B prime, and this is C prime. So -2, 1 is A prime, -2, 4 is our B prime, and -4, 3 is C prime. Okay. So the blue triangle there is our original, and the red triangle is what we have after we rotated 90 degrees about the origin. And here what we have is the image matrix of that, starting with the original and performing the transformation quite quickly on all 3 of these points to get our result. There you have it. Thank you for watching, and as always, if you have any problems or questions, please ask for help. Have a wonderful day.